तौर पे उनके लिए काफी जरूरी
Hello.
Good afternoon, sir.
Am I audible?
Afternoon, sir.
Good afternoon.
Yes, sir.
Yes,
Good
sir.
afternoon, sir.
Afternoon. Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Yeah, I am waiting for Professor Kumbhakar. Um, not sure if he has joined here yet.
Sir, you are not audible.
Can you hear me
Yes,
now?
sir. You are audible, sir. Yes, sir.
Okay.
Yes,
Sir,
sir.
Yes, sir. Actually, your voice is coming very low.
Good afternoon.
Yes, sir. You are
Yeah.
audible.
Yeah. Okay.
Yes, your voice is.
My voice is too low. Is my voice too low?
Yes, sir. Yes.
Yes, sir. You can increase.
Kind of.
No, sir, it is fine.
Okay. I have no way of increasing the volume of my
It's
mic.
enough, sir.
No, sir, it's fine.
Yeah, sir. Now it's all right.
All right.
Fine, sir.
All right. So I am not sure if others have joined. The PhD students, they are supposed to be your mentors for the sessional course. They will be handling everything, and they have not joined yet, I guess.
Sir, I have
Okay.
joined.
Uh,
Sir, I am here, sir.
Parthiya, oh,
Good
okay, good.
afternoon.
Yeah, good afternoon. And Arindam there?
Yes, sir. I'm
Yeah,
here, sir.
thank you. Thank you. So your students, your mentors for this course is going to be Parthasarathi Sahu, a PhD candidate in physics department, and Arindam Devi is also a PhD candidate in the physics department. Okay, they will be handling the instructions, collecting the reports, evaluating the reports, administering Viva, and giving you marks. So it's they'll be handling the day-to-day activities of this course. Okay, and I and Professor Kumbhakar will be taking a backseat, and if there is any issues, we will step in. Does that make sense? Is that clear?
Yes, sir. It's all right.
Okay.
Yes, sir.
All right. And the other point is that you will be grouped into distinct groups. Like I'm not sure if we are like 92 people, I guess 92 or 96 or whatever. So there'll be 8 students per group. All right, 8 students per group, and if there are students left over, then they will form a group, a smaller group perhaps. All right, the grouping is going to go on according to your roll numbers. Okay, so 1 to 8 is the first group, 9 to 16 second group, and so on. Okay, am I clear?
Yes, sir.
All right, so the purpose of a group is this: you will be doing online experiments. All right, and there is not much of a variation between experimental results, experimental numbers. Okay, so each group, you will perform the experiment once, get the data for all of your members of the group. So your data for a specific group, the data can be the same. Okay, it doesn't have to be the same, the data can be same. Okay, you can choose to make your own readings if you want, but you can use the readings of members within your group. You cannot use data of members outside your group. Okay. Okay. Each group should perform a distinct experiment with distinct data. Okay.
Yes, sir.
Okay. And as for reports, after the experiment is done, you will have 2 weeks to send in your reports. Okay, we will create a dedicated email, Gmail or whatever Gmail, it's in Gmail or whatever. We will create a specific email and share it with you guys, so you can send your lab reports in a specific format. We will also let you know the format. Okay, what format you have to send your reports in, right? So you will be sending your reports in PDF format to the specific email ID, which will be given to you as well. Okay, every one of you must send in a report. Okay, your reports will be evaluated, and each report I'm not sure how much. There's going to be 4 experiments, I guess. So your reports would account for about 60 to 80 marks. Okay, from 60% to 80% of your credits come from your report. So be careful with your reports. Okay, the rest of the marks come from Viva, which will be conducted at the end of the semester. Okay, am I clear?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
Okay. All right. Okay. Number 3, the kind of experiments that you will be performing. Okay, there will be 4 experiments. Let me tell you the experiments that we'll be doing. Hold on a second. Let me pull out. Okay, so the experiments there are 4 experiments. The first experiment is a refractive index of a liquid using a traveling microscope, right? That probably comes later. The second experiment is Brewster's law and Malus law. And the third experiment is interference of light using Newton's rings apparatus. And 4 is Planck's constant. Okay, these are the 4 experiments that you will be doing. You will be taught how to do those experiments. These are online experiments. Remember, these are online experiments. No, hardware, nothing required. You're just going to sit in front of your computer and play with the buttons on the browser, on your web browser. There are no softwares to be installed. It'll be all on web-based software experiments. Okay, and you will be taught these experiments by the PhD candidates, Partho and Arindam. And if you have any doubts, you can ask them during the class. Okay, and you will be communicating with them. If you have any issues, you will communicate with the students, with the PhD students. All right. The reporting format, the format of the report will be sent to you. As I said before, the email will be sent to you. Okay. And if we decide to add another practical, we will let you know. Okay. For now, it is 4 experiments. All right. Any questions thus far?
No, sir.
No, sir.
Okay. Okay. So, how many students are there? CRs? Do you have any idea, Anindita?
Sir, there are maximum 90 students. 86.
86.
Sorry, sir, 92. 92 last roll number.
Okay, last roll number is 92. Okay, maybe there are some students missing. Okay, let me do the grouping then. Okay, I will do the grouping, or I'll ask the students, the PhD students, to do the grouping. Okay, maybe some students are missing, so we have to, yeah.
Sir,
Yeah.
do you have to maintain any kind of record or lab record or something, or do we need to submit only the reports?
You have to submit the reports in a PDF format. There is no record that needs to be maintained. You have to submit the reports as a PDF. Okay.
So the report is to be handwritten, or it will be a PowerPoint presentation, or what form it will take?
Good question. There's been a considerable arguments over which is better. Okay. But because your seniors have been meddling, and basically if it is typed, then there is enough copying going around. So the rule is handwritten with interspersed images of your experiment. And if you're plotting the data on Excel sheet, then the images of those. Okay, but it will be handwritten. It will be primarily handwritten with inserted images from Excel or your web browser. Does that make sense?
Okay, sir.
So every one of you must write it in your own hands with your name, roll number, and the date. Okay, in your own handwriting, and you will use images from the web browser. If you're taking data, you would want to use print screen and make it into an image. Okay, and insert it into your file, PDF file. Okay, pull it, pull it all together and make it a report. Okay, if you're plotting your data, you'll be using Excel, plot the data, or if you want to use a graph paper, you're welcome to use a graph paper. Take a picture of that, include that in your report. But it will be handwritten, that is for sure. Okay, good question. Thanks for reminding. Okay.
Okay, sir.
All right.
Okay, sir.
All right. Pretty much that's it. I don't think there is anything else to cover. Are there any questions?
No, sir.
Nothing. Okay. Okay. Then I guess that is for today. That is it for today. Okay.
Sir.
Yeah.
Sir, could you please repeat the 4 experiments you have mentioned?
Okay. The first is the refractive index of a liquid by a traveling microscope. Okay. You'll be measuring the refractive index, how fast light travels through a liquid. Okay. And the second is Brewster's law and Malus law. Okay. You would have learned about that in your optics class, right?
Right, sir.
Okay. How your polarized light changes its intensity as you change the polarizer angle. Okay. That is the second law, second thing. And the third is interference of light by Newton's ring apparatus. Okay. You will see we have nice visualization online. So there are experiments that you can do online. You can vary curvature and all that. So curvature of the lens and all that. Okay. And that is here. I guess you're going to measure the thickness, or the refractive index. I'm not sure which one, either one. Okay, and the fourth is Planck's constant. Okay, measurement of Planck's constant. Okay.
So when will our lab classes will start?
Next week, as soon as we can.
Sir, every
Sir, through
Monday.
which online portal?
Sir,
Yeah.
sir, every Monday, yeah, or all day.
When is your class, by the way? When is according to the schedule? What is the time?
Sir,
Tuesday.
Thursday.
Tuesday? Yeah, then it'll be on Tuesday. It'll be on Tuesday at 2 p.m. Right?
Okay, sir.
That's when your class will be. Okay.
Sir, through
And,
which online platform we will do
yeah, yeah, that's
experiments?
so I want to answer that question also. It'll be through MS Teams, but it will not be on this channel, hopefully. Okay, it'll be on a separate channel. So there are channels in your teams, right? For engineering chemistry, engineering physics, and all that. So there'll be a separate channel for sessionals, PHS01.
So no, sir, he's asking in what kind of website do we need to do those visualization?
Yes, sir.
And
Okay. That you will. Yeah, that you will. Okay. By the way, we will also be sending you guys the PPTs, the PowerPoint presentations. Okay. So you will have the link. You will have the link in the PowerPoint presentation. Link for the website.
Okay.
Wherever it is.
Okay, sir. Okay. Okay, sir.
Yeah, so you will get the PPTs, no problem. It'll be uploaded on MS Teams, and everybody will have access to that. Okay, and again, I want to remind you guys, one of you should make sure that you download the demonstration videos, upload it in the file section of the channel. Okay, like I've requested you guys to do this for the courses. I think you guys are doing it. I'm not sure. Someone please download it. Someone take the responsibility of downloading the lectures and uploading it in the appropriate file section. Okay, for both lectures and sessionals, please do that so everybody will have access to those files. Because after a certain period of time, these lectures will be gone off of the website, off of the MS Teams if you do not download it. Okay, does it make sense?
Okay. Okay,
Yeah.
sir. Okay.
Please do it within a couple of weeks after the lecture is over, after the sessional lecture is over, whatever. Please download it within a couple of weeks and then upload it again. Okay, so we'll have a central place where we can refer to the lectures later on. All right. Yeah, someone should take the responsibility of that. Okay, I don't want to load the CRs with that responsibility. Someone else, maybe the CR can identify someone else who can do that with enough bandwidth if they have enough bandwidth. Internet bandwidth. Yeah.
Okay, sir.
Okay. All right. And that's about it. Are there any questions?
So as we have enough time left, can you take the theory class?
Now you mean?
Yes, sir.
No, sir. Like,
If you want to talk about something else, we can talk about something else. May not the theory class, but I don't know how others are going to feel about it. If you want to talk about something else, we can certainly do that. You guys have some questions about something else? You can always ask me. Yeah.
In the schedule we have our CA examination from 10th. So what will be that? I mean, for that, can you tell us something about regarding that?
10th. Oh, that's too soon. It's been just a couple of weeks now. Okay.
Yes.
sir.
Okay. So number one, your exams will be on Moodle. Okay, moodle.nitdgp.ac.in. That will be the website, and please make sure you have access to Moodle. Okay, everybody should have access to Moodle. You should sign in, maybe change your password, and make sure that you are enrolled. Okay, I will enroll all of you into Moodle. I will create a team there for this class, and your exams, your quiz will be on Moodle. Okay, it'll be a quiz. It'll be an MCQ type quiz, and the syllabus is up to whatever I have taught, whatever I would have taught by the end of this week. Okay, we'll have a couple of classes this week, I guess. So whatever we've been teaching until then would be the syllabus. Okay, because we haven't covered much of anything at all. So it should be pretty easy for you. Okay, and number two, about the time, whatever is preferable for you. I don't want to go by the centrally determined time. Okay, whichever, if you're feeling okay with the evening time, you can always let me know. Okay, you can fix the timing according to your own preference. Okay, but within the week. All right.
Okay, sir.
Okay, and it'll be MCQ. It'll be for 15 marks. So yeah, there will be around 10 to 15 questions, MCQ type questions, and you will probably have around 40 minutes. Depending upon how many questions I will set, it'll be around 30 to 40 minutes.
And so the syllabus will be, I mean, the examination will be including both of the part, that is your part and.
Absolutely, yes, absolutely, yes. Yeah, it'll be, if it is like 10 questions, then 5 are from optics and 5 are from non-optics. Yes. Yeah. Okay. So from my part, at least, let me tell you what kind of questions that I would set from my part. It's going to be entirely conceptual. Okay. So if you understand, you will be able to answer that. If you have listened to the lectures, you should be able to answer that. You don't have to go through any book or material. Okay. If you understand something intuitively, you should be able to answer those questions. And that's basically how I design my questions. I test your understanding. Okay. I don't test your numerical capability. I don't test your calculational capability. I don't test your memory, particularly no memory. Okay. You don't have to memorize anything at all. Okay. I test your understanding. That's it. Okay.
So like by giving situations.
Yeah, something like that. Yeah. Okay. Okay, that's for my section. Okay, that's for just 5 marks, five questions or 6 questions or whatever. Okay. Any other questions? Anything else that we can talk about? Do you want to? If you want to clarify stuff from your theory classes, you can do it now. If you want to hang on.
Sir, will the exam pattern be based on different sections because the pace of the syllabus is different for different sections?
Absolutely, yes. So for our section, it'll be whatever we've been teaching. And for other sections, they will have a completely different format. They can have different format. They can maybe ask you guys to ask their students to give a report or something. It'll be independent. Okay, for different sections. But the final exam will be of the same format for all sections.
Okay, sir.
Okay. Yeah. Yeah, but don't put too much of an emphasis on the exams. Okay. Exams are, it's more, from my side, it's more of a distraction than, than a proper evaluating opportunity. I don't think it evaluates. I don't think it allows any kind of evaluation, reasonable evaluation. Okay. Hold on a second. Yeah, hi. Okay. So where were we? Yeah, examinations are distraction basically, because there is no way of evaluating individual capabilities in a single format for all students. Each of you are unique. Okay, each student is a unique individual. They have unique capabilities. They are creative in their own way, and the examination doesn't measure any of that. The examination measures whatever you've captured, listening to the lectures, reading the books, and all that. That's maybe not very useful. Okay, don't put too much of an emphasis on exams and outcomes of exams. Okay, it treats every human being has the same thing, which is not true at all. I guess you guys understand that. You're all unique. You have unique capabilities. You have a unique place in the world. Does it make sense?
Yes, sir.
So exams are bad in that respect, particularly in India. They are really bad because it puts everybody on the same pedestal. A person who grew up in the backwaters, in the villages, he knows more about plants, he knows more about games, he knows more about other things, but he doesn't know more about how to navigate the city. His knowledge base is completely different. How do you evaluate him, put him on the same pedestal as a guy who was brought up in the city? Totally different scenarios. They thrive in different places. Okay, you cannot evaluate them on the same pedestal. The way someone is educated coming from a government school and the way someone else has been brought up from a different kind of school, they're not the same. How do you evaluate them? How do you bring them up to speed? You cannot put them on the same pedestal. That's unfair. Okay. Unfortunately, we cannot test your uniqueness. Okay, because we have 800 students and like 8 professors. So, we have to club them together. Okay, we are only looking at averages, which is really bad. Okay, so in that sense, educational system does a big disservice to all the uniqueness in the world. Okay, educational system destroys uniqueness, destroys creativity. Creativity is always unique. When you create something, it is unique. If you're creating the same thing like other, it is not creativity at all. But we're not testing creativity at all. We're dumbing down creativity. The world needs more creators, not more followers. We are all making more followers. We are feeding the industries with workers. That's what most of you are going to end up as. You will be workers for somebody who is, some industry. Okay, which is not an optimal use of your energy. It's not. You should be creating. You should be entrepreneurs. You should be creative. Which is not what we are doing, unfortunately.
Sir,
Yeah.
sir, in the last class, you were telling us about that how the antenna captures that EM waves, like from that voltage difference. If you want, we can continue that today. Like if it's feasible.
Okay. You guys want to learn more about that?
Yes, sir.
Yes, sir.
If it's feasible for everyone and for you also.
Yeah.
Like,
If you guys want to, if any of you want to leave, you can leave. I'm not going to hold you down against your will. Okay. So if anybody wants to leave, you certainly can. I'm just gonna pander to the curious guys there. Just a minute. Let me connect my my tablet. Hold on a second. Partho and Arindam, if you want to leave, you can also leave. Thank you.
Okay, sir. Thank you.
So yeah,
Thank you. Yeah. Okay, let me share my screen. It's pretty simple, actually. Are you able to see my screen?
yes, sir.
Okay.
Yes, sir.
So
Yes, sir.
yeah, the idea is pretty simple, right? So you have an electromagnetic radiation coming in. Okay. You have an electromagnetic radiation. Let's say it's propagating along x direction, and it is oscillating along y direction. Let's say the electric field is oscillating along y direction, like that. Okay. And you have an antenna. It's just a single rod. Let's say just a single rod. All right. Now, the moment this electric field, the electric field along, let's say this one goes through this antenna, let's say, Oops, sorry. Okay, which direction is the electron going to be pushed in? In the tube, in the aluminum tube. We have an aluminum tube, okay, and the electric field is passing on like that. Which direction is this going to be pushed in?
So electron is going to be pushed opposite to the electric field.
Yeah, exactly. So here the electrons are going to be pushed here. So this will be negative and this will be positive, right? Am I right?
So actually
Yes,
opposite
sir.
to the electric field, then X, the electric field is like, if I see, then it should be pulled towards negative now. Can you explain this? I'm not getting it.
EF equals EE minus E. Okay.
Yes, sir.
So the electric field E is along this direction.
Yes,
So
sir. So the
force of
electrons should be pushed towards negative,
yes,
the negative
yeah,
sign. Yeah.
negative side. Okay, so electrons are here, more on this side. There are more electrons on this side,
Yes.
the bottom side, than on the right side. Okay, so the right side becomes positive and the left side becomes negative. The bottom side becomes negative. Okay, and what you're doing is you're connecting wires across that, and you can measure with an voltmeter. Okay, all right, and that is when the electric field goes this side, and after that, when the electric field comes this side to this side, the polarities change, right? This becomes negative and this becomes positive, right?
Yes, sir. Yes, sir.
So the voltage becomes an oscillatory voltage with the same frequency as your electric field, as your frequency of your wave. Does that make sense?
Yes, sir.
Okay. So you can use this. You can take this and you can. This is carrier frequency. The information is encoded in the carrier frequency. Okay, the information can be in different frequencies, but it's encoded in a carrier frequency. That's a frequency modulation, and you can basically decode that, remove the carrier frequency, and extract the information from it. And that's all DSP, digital signal processing. That is the job of digital signal processing. Okay, you should learn more about Fourier transforms and all that. How to extract information from the carrier frequency is all about Fourier transforms.
So what will be the effect of the magnetic field component here?
Not much, actually. Magnetic field, energetically, magnetic field is quite weak. Okay, magnetic field, of course, here the magnetic field helps in propagating, propagation of the wave. Okay, without the magnetic field, there will be no wave. Okay, because the change in magnetic field creates electric field, and the change in electric field creates magnetic field, and they create each other as they move forward. Okay, that is electromagnetic wave, the whole thing. But on the aluminum metal, the magnetic field is not going to create much of a difference. Okay, it is the electric field that matters more.
So is it due to the magnitude that is 10 to the power 8 times more?
It's because of the difference between mu naught and epsilon naught. Yes.
Okay.
Mu naught is weaker. Yes. So in that sense, the magnetic field can be completely ignored energetically. Okay. So the point I was trying to make is that if you have an antenna that emits electromagnetic radiation, and if you have, sorry, this is a transmitter that emits electromagnetic radiation, and if you have an antenna, and the antenna is really close to the transmitter, then the voltage is going to be very high. It's like an order of millivolts or something. You can extract energy from the antenna itself. You don't have to have batteries to run your radio. You can just use the antenna itself as a radio, as the energy source. The antenna both collects information and energy at the same time. Okay, but if you're far away from the transmitter, you cannot extract much energy. Okay, and here, if you're keen, if you have been observing me keenly, the frequency of the oscillation of the voltage across the antenna is very high. The frequency of the electromagnetic wave, it is the frequency of the electromagnetic wave. It's really high. Okay, are the electrons moving at that frequency? The question is,
Sir,
are the
do
electrons?
sir, do humans absorb EM waves also?
Do what absorb EM waves?
So humans like us.
Humans, yeah, specific frequencies, right? It depends on frequencies. What frequencies? See, water molecules absorb microwave frequencies, right? So if you send in microwaves through human body, we will absorb it. Okay, we're basically 70% water, right? And we're made of carbon bonds. And what frequency does carbon bond oscillate in? A carbon bond. It's an ultraviolet, deep ultraviolet. Okay, so if you send in a deep ultraviolet radiation, the DNAs break because they are made of carbon bonds. They break, and that's what creates dangerous, carcinogenic situation. It becomes carcinogenic. That's why you want to avoid ultraviolet. Okay, you've seen cricket players draped in sunscreen, particularly Australians. Have you noticed?
Yes, sir.
Yes, sir.
Yes, sir.
Why do they apply sunscreen?
To protect the screen.
Yeah, but why particularly Australians?
So
Because
they are
on
not
the South
habituated
Pole
to
there is
that.
a ozone hole.
Exactly. Yeah, there was a ozone hole. Now it has healed to some extent because we banned CFCs, chlorofluorocarbons. We banned them, but still there is a huge amount of UV radiation that comes through in the South Pole, and Australia is very notorious for high UV radiation. Okay, so when you look at any weather report, you will see UV index. Even in India, we have UV index. Okay, at the certain times of the day, if you're in a higher latitudes, like near Himalayas, your UV index can be really high. Okay, so you need to have sunscreen there, right? And that is because UV radiation can damage your DNA. Okay, whereas infrared radiation, it doesn't do anything to your body. It just heats you up a little bit. Okay, regular light, it doesn't do anything. Like green light, yellow light doesn't do anything. Okay, so it depends on the kind of frequencies that you choose. Okay. Okay.
So nowadays UV sanitizers are also there, so they are also harmful. That means.
What UV what?
So UV sanitizers in the markets, they are available now for
Absolutely,
the.
absolutely. You don't want to look into them. Absolutely, they are. That's one of the reasons why they are regulated. Okay, they are regulated medical devices. They are not really, in India they are free moving, but they should be regulated, and they are regulated in many Western countries. Okay, you cannot nobody can just sell UV sanitizers. That's not right. If you have water purifier in your home,
Yes, sir.
yeah, most of these
UV
water
tube is
purifiers have a UV light
UV
in it.
tube.
Yes, they have a UV purification chamber in them. Almost all of them will have
Yes,
that.
sir.
Okay.
So you were talking about the electron frequency of that.
Yeah. So let's say this antenna is 1/4 of a meter. Okay. Do the electrons really travel from the positive end to negative end, or negative end to positive end at that frequency? Do they really do that?
No, sir.
No, sir.
No, sir. Energy
They
is
just
travel.
vibrate at that position.
Yes, very good. So many of you have watched that Veritasium's video. You
So
guys have watched
energy,
the video? I'm sorry? I'm sorry?
energy,
Yeah,
sir. So they
yeah,
vibrate and transfer.
yeah. It vibrates and transfers energy. Veritasium actually talks about that. In the channel, YouTube channel Veritasium, the guy actually talks about that. Yeah. So basically, it's not the electron that is moving. It is the electric field that is changing. It is the electric field, the interaction between electrons within this aluminum tube that change. Okay, and the electric field travels at the speed of light. So it is just a field that oscillates inside the tube as well. The electrons don't do much. They just vibrate in their same position, same location. Okay. Okay, and that
So,
is what, yeah.
but doesn't the principle of superpositions help? Because there are like thousands or at least hundreds of frequencies and electromagnetic waves in the atmosphere and the region where the antenna is placed. So don't these interfere or do something like chaos? Don't these create chaos?
It's not chaos because this is a linear system. Okay, it's a linear system, and so basically there is a, so you have an antenna. That's a good question. So you have multiple waves from multiple channels. Like you have a Singaporean channel, you have a Malaysian channel, you have a Sri Lankan channel, and you have Indian channel. They all operate at different frequencies, let's say. Okay, and all of them, of course, impinge on the antenna. You're right. All of them impinge on the antenna. You get the data from all of them, and you plot them in time. Let's say this is your amplitude of the voltage oscillation, and this is the time of the voltage oscillation. You will see something like this, really high oscillation, something like that, right? How can you figure out which one belongs to which? That is what the radio does. Okay, when you tune, it picks out Indian channel, it picks out Sri Lankan channel, it picks out Malaysian channel, or whatever.
Sir, it does it use the Fourier transformation of like taking out the sine waves from the multiple waves, like adding up? Does it just Fourier?
Very
May
good.
it can be done using LC circuit?
Yes, it is done using XC circuit, but the answer is Fourier transforms. It is
Fourier
done using LC
transformation.
circuit. Answer is Fourier transform. So what you do is, it's a Fourier transform is a, let's say it's an operation where you put in a lot of frequencies, and you can, by tuning, you can extract specific frequencies. Okay, you can extract particularly omega 1, omega 2, omega 3. You can actually extract specific frequencies.
So is it based on the resonance condition of LCR circuit?
Very good. Yes, exactly. That is the way that radios extract specific frequencies using LCR circuits. Yes, but LCR circuits basically enhance one particular frequency over others. Okay, but if you want to extract all frequencies at the same time, you use Fourier transform. Okay, it's like a prism. Imagine Fourier transform like a prism. Okay, like what a prism does. There is sunlight. Okay, and what does the prism do?
It scatters the white light into multiple waves.
Separates the different wavelengths.
Yeah, multiple different wavelengths, which means different frequencies. It separates omega 1, omega 2, omega 3, omega 4 with a specific lambda 1, lambda 2, lambda 3, lambda 4, and all that. Right? So what it does is basically separate out all the frequencies. Just like that, if you're in your Fourier transforms, you send in a single signal, which is a composite of a lot of frequencies. The Fourier transform actually gives out many frequencies. All the frequencies. Basically, it gives out all the frequencies. Okay, and it's a beautiful, neat technique. You will be studying that technique in your mathematics course. If you want, I can teach it too. So basically, to separate out the frequencies, then you can look at each frequency by itself separately. Okay, you can do that on a computer. If you want, we can write a code together, MATLAB code or a Python code or whatever you guys are comfortable with. We can write a code to do Fourier transforms. Actually, we can demonstrate Fourier transforms using.
Sir, now one more question is there.
Yeah.
Sir, can a mechanical radio be made? Because last night only I saw a video in which Lord Kelvin actually took the tidal frequencies and actually separated in like 1910s and like made it.
Very good. I saw that video too. Yes.
Can we do it? Can we do it without any electrical device and like just like using pulleys and all, like Lord Kelvin did that in like 1910s?
That is exactly what he did. That is exactly what he did, because tidal waves are composites of many frequencies. It is a lunar motion, it's a solar motion, it's the Earth's motion. So there are many frequencies that are overlapped. Okay, so he made sure he managed these pulleys to separate out all these frequencies and find the Fourier coefficients. But once you find the Fourier coefficients, you can predict tidal.
So we can't hear you. So you're not audible. So. Sir left?
Yes, sir has left. Maybe he will join.
Yes, I guess.
Hello, can you hear me?
Yes, sir, you are audible.
Yeah, okay.
Yes.
Yeah, that's a good question. I think everybody should go and watch that video. I think it was, I'm not sure if it is 3 Blue 1 Brown or Veritasium or.
Sir, Veritasium.
It's Veritasium? Yeah, okay, yeah. Everybody should go and watch that video. It's a very good video. It's a wonderful demonstration.
So it's a recent one.
So when was it uploaded?
It was maybe last week.
10 days ago. 10 days ago.
Yeah. Yeah.
It's very recent.
It's a recent one, yes. And remember, Lord Kelvin was known for thermodynamics. Okay. And these are the guys who basically dabble in every field. Okay, not just in thermodynamics. He's known for Kelvin. He's known for the second law of thermodynamics. I mean, Kelvin statement. There's something called Kelvin's statement. I'm not sure if you guys know about that. But he contributed in a lot of fields, not just one. Anyway, it's a very good video. Yes, you can certainly do that using mechanical analogs, of course. I mean, that can be your project. You know, you can do that as a project, as your side project. You can also instead of doing it by hand, you can also use physics softwares like COMSOL. Have you guys heard of this software called COMSOL?
No, sir.
There are physics-based softwares which can simulate physics systems. It can simulate systems. So you can basically design these pulleys using those software. You don't have to really go down and buy these pulleys and ropes and do that yourself. You can actually simulate them online. Okay, and you can test out how these pulleys actually do the Fourier transformation. Okay, these are really cool devices, amazingly cool devices. Yes, analog. Yeah, the title of the thing is analog computers.
So one question.
Yeah.
So if you have, as Aditya said, that can we use magnetic field to do the things that we are doing by electric fields? So if you are doing that thing, that is the magnetic field is going to affect by the Earth's magnetism.
No, he
Not
has
magnetic field.
yeah,
Actually, I'm talking
mechanical.
about mechanical,
Yeah,
magnetic, mechanical things.
Yeah, 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 yeah. Earth's magnetic field is really weak, and it's not. It's quite weak. Okay, and it flips every now and then. Over hundreds of thousands of years, magnetic fields flip of Earth. Okay, and we possibly are closing in on another flip event. There is a possibility. Okay, so electric actually, it looks like the circulation inside Earth is flipping. It's going to go in the opposite direction because the Earth's magnetic field is moving around near the poles quite a bit these days.
Sir, if this event happens, do we need to change the poles of Earth?
No, the magnetic pole is going to be changed. Geographical pole is the same. You have north and south, but the magnetic poles are going to be changed. But then it's not. It's what the heck? What is going on? Is there an issue? Can you hear me now?
Yes, sir.
Yes,
Yeah,
sir.
I don't know what's going on.
Yes, sir.
There's some issue. Okay,
Yes, sir.
so the magnetic poles do change, but the thing is that during the change itself, things become a lot more dangerous because the magnetic poles actually save us from solar storms, right? So,
Yes, sir. How, sir?
so I'm sorry.
How, sir?
But
Like,
does the sudden slip occur?
Yeah, basically because you have Earth, oops, and you have the magnetic field like that. Magnetic field goes down like that, right? Sorry. And the solar storm, these are charged particles, okay, from the sun. And when these charged particles come, they get trapped in the magnetic field and they get circled to the North Pole and the South Pole, okay? And there they get burned, meaning that they collide with the atmosphere and create these auroras, okay? But without the magnetic field, these particles will directly come into the Earth's surface, okay? And it becomes really dangerous. And the Earth satellites, most of the satellites will be burned as well. Okay, the electronics will be damaged as well in solar storms. So there have been incidents where the whole electric networks can get damaged during a strong solar storm.
So then how does the spacecraft come back to the Earth?
They do not come back, they burn.
So like right now that SpaceX have sent a aircraft, the spaceship, and when it came back, so how did it get?
so reusable.
Yeah, those are
reusable
reusable
missiles.
rockets. Yeah, those are reusable rockets. Okay, well, I'm talking about satellites. Satellites do usually burn because they get parked at a higher radius, and when they move through atmosphere at very high speeds, they burn. But these rockets also acquire quite a bit of energy. They have to be designed specifically to withstand high temperatures during re-entry. Okay, so the SpaceX design basically withstands all the high temperatures. If you've seen Apollo 13, Have you guys seen the movie Apollo 13?
No, sir.
It's
No,
an
sir.
old movie. Watch that. It's a beautiful movie. I think it's Tom Hanks. I don't know. I don't remember who that was. Tom Hanks, I think. Yeah.
So
So
Kalpana Chawla's also that incident we have
yeah,
heard
yeah,
about
we
that.
have we have that. That's a disintegrating. That's a unfortunate incident. Yes, but we have successful incidents as well, like Apollo 13. Many people have gone to moon and come back to Earth, and they've sailed through the atmosphere without getting hurt because the re-entry craft is designed to withstand very high temperatures. Okay, same with SpaceX
Sir,
re-entry vehicle. Yeah.
Sir, now I would like to ask a political question. Like, how much do you think is it ethical that NASA recently granted Blue Origin and SpaceX satellites permission of like 45,000 satellites to SpaceX and like 37,000 satellites for the
Sir, we are
Blue
talking
Origin?
about
Like, how can NASA take the responsibility of the whole world? The space and the atmosphere belongs to the whole world. How can NASA alone take that responsibility? Isn't it unfair to ISRO and another space organizations?
Okay, okay. Someone else also butted in something. Is there any another question that I can answer together?
sir,
Someone
we
else?
So
were
when will our moon mission be accomplished? ISRO.
Okay. Yeah, but there was another question related to the SpaceX. Is there another question related to SpaceX? Yeah. Okay. Let me answer that question. Okay. Of course, no. There is always a gray area. But remember, everybody in India uses Facebook. Everybody in India uses Twitter. Okay. Almost everybody. WhatsApp. Okay. Where are these companies located?
Bay Area, San Francisco.
Yeah,
They're in
yeah,
United
US. Basically, they are US based companies,
So
right?
they are American based.
They are US based companies, yes. So these companies are transnational companies. They are not, even though they are located in the US, these are transnational companies. They are not answerable to a single jurisdiction. They are answerable to all jurisdictions. Okay, Facebook or Google, they get sued in Europe. Google gets sued every year almost in Europe. Okay, and India also calls Twitter Twitter CEOs every now and then. It calls to
Yes,
the
sir.
committees, to investigative committees, every now and then, right? These are supranational companies. So if you say NASA just gives them the thing, that is not true. In fact, okay, there are international rules of how space can be used for peaceful purposes, and SpaceX is exploiting the holes in that organization. Okay, there is a system in place which allocates how many objects in space you can park. Every country can park, right? You cannot crowd that space, right? But SpaceX does that nevertheless. Okay, the reason is that the motivation behind SpaceX, the whole idea is universal internet for everybody, right? It is a possibility that you can just buy for $100. Even today, even though it is illegal in India, you can buy for $100, maybe $200 at max. You can buy the receiver and extract and get information connected to internet through SpaceX satellites, sitting anywhere in the world.
No, sir, it's currently $1,300 in US also. It's $1,300. That's why I was comparing it so expensive. Then if it's like legalized in the whole world, then India will suffer the most because today we pay 500 rupees, that approximately $6 to $7.
That is true, but economy always wins. If this is cheap, we will go for cheap. Nobody is going to force us to buy a SpaceX thing. Okay, I think it was a projected amount. I'm not sure if it is 200 or 100. Maybe it is a projected amount. Maybe you're right. I don't know exactly the amount. Okay, but it is going to come down. Okay, as they scale up, it will come down. Okay, and that is their noble cause, by the way. That is their noble purpose. That is the noble purpose behind it. But Elon Musk is not a noble person. He looks for profits. And where does the profit for these orbiting satellites come from? How does he get the money?
So from his investors.
But the investors have to believe that they will get their money back
So
eventually.
from sending data, because we are using their satellite as a bandwidth, so
Yeah,
that's
but
a
they
so
will
that
they will get some amount, but that is not merely enough to satisfy all those rocket launches. They have to launch hundreds of launches every
So,
time.
so
So
currently the NASA is
Russian space
funding
agency.
SpaceX now.
Providing
I'm
some.
sorry.
So currently,
So
like
Russia is
for some
funding
previous
SpaceX.
projects, NASA has funded SpaceX like for $2 billion, something like deals are there with NASA.
That was early days, not now.
Yes.
Now
Sir, is
SpaceX
So
it because of the
nowadays
stocks
NASA
of
is funding Blue
Tesla?
Origin.
Because the stocks are at all-time high for Tesla last year.
Sir, SpaceX.
it's okay. Tesla and SpaceX are a little different. Tesla has, so SpaceX is
Yes.
just one part of Tesla, one part of the whole empire. But let me tell
Sir,
you where the money comes
so
from.
they're
Sir,
promising their investors that they will make this space travel open for everyone, and the it will be commercially available, the space thing and space
Yeah, but
travel
the
and
Still,
cost
everything.
will be too
still,
high, and it is not practical.
yeah, it is not practical. Not everybody is going to go to space. Okay, not
sir,
everybody is rich enough to go to space. Yeah.
sir, I think SpaceX is sending the useful stuff, whatever is needed in space station. So that's why to send those instruments or whatever is required to run the space station properly there, SpaceX is taking those responsibility, and for that NASA is paying SpaceX company.
Okay. Yeah. All of these are plausible answers, but they are not nearly enough. They are not nearly
And
enough for the money that they spend.
I think moreover now Starlink is growing, and he's sending 2000s of satellites there in order to capture those telecommunication market all across the world. So in
Yeah.
that sense, and obviously he has the biggest money resource in his Tesla, and he's selling his Tesla stocks more than I listened to that maybe some 0.2% of shares he has already sold, and so I think
5%. That's all.
5%. Oh, sorry,
Yeah.
sir. And I
Yeah.
think he's using those money in SpaceX projects.
Yeah, but the question is, how is he going to recoup that money? How is he going to get back the money? Let me answer this question. Okay,
Yeah.
the way he's going to recoup that money is by sharing financial data. You know, the first cable, the first long distance telegraph cable that was laid between New York and London, that was more than 100 or 150 years ago. Why was that laid? Okay, the most of the times technology improvement happens because financial incentives are much larger, right? So the financial market of New York and London, okay, there is a time lag between the financial markets, right? The financial market, let's say the cable that goes from New York to London, there is a New York financial market like New York Stock Exchange, and there is a London Stock Exchange. Okay, and the price of dollar in NYSE and London Stock Exchange differs by a millisecond. What is going to happen? Okay, if somebody can extract information faster than 1 millisecond, if somebody knows the New York Stock Exchange value of dollar in New York Stock Exchange before 1 millisecond at London Stock Exchange, they can change their price. They can buy more dollars, sell more dollars at the rate of at the frequency of milliseconds and make money. It's called high frequency trading. It's called high
Yes, I
frequency
have
trading.
heard about it.
Okay, so these cables operate at millisecond speed, extremely fast. What Elon Musk is doing is he's aiming to bring down that time. He wants to do it in 17 milliseconds, if I remember right, out of 34 or 40 milliseconds for the regular cable. He wants to do it much faster. Okay, and if he does much faster, he basically disrupts the whole financial market across the world. Okay, he can charge the people who do this high frequency trading, and these people make trillions of dollars a year just by trading alone. Okay, and he is using his Starlink to provide a faster channel for sharing financial information across stock exchanges. That is the primary reason behind his Starlink project.
Sir, so now I want to discuss something like interesting. Like whenever I discuss something like blockchain and like Web 3.0, I'm actually not that very much optimistic about Web 3.0. because now I want to discuss it now, because like in the World War II, if we see the Enigma and the codes, the Morse code, Enigma machine, and all were extremely like high profile machines and high profile mathematics was involved. But when the time of need came, someone in the London, I don't remember, not John Nash, Alan Turing broke the code. So at when the time will arrive that it will be an emergency in the situation, like imagine the World War III or a global financial crisis, someone will break the blockchain. We can't depend on maths for the whole economy of the world. So like the thing that every country is like, many countries are like going towards the official blockchain and all, like it's all dependent on maths and there is no human for that economical purpose. So is that okay? I'm actually completely pessimist because I believe that economics and money should be somewhat controlled by humans and not by mathematics. Like someone can use his full power to actually break all these blockchain codes and like something do extraordinary, and then like the whole economy of the world will collapse in one. So the at the pace we are going towards blockchain, it's very dangerous according to me. So what do you think about it?
Okay.
That's why, sir, India is bringing its own regulated token. Like
Digital
it's
currency. Okay. Okay. You've gone. Yeah.
Sir, can I leave?
Yeah. Please. Yeah. If you don't. Yeah. Please.
Okay, sir.
Yeah.
Thank you,
Feel
sir.
free. Feel free to. Yeah. So
Thank you, sir.
let's get
So
to the
we have
question.
another class at 3 p.m.
Oh.
The
Okay.
A1 language class, so we can leave.
Okay, then we will talk about Web3 some other day. Okay, we will talk about Web3 and blockchain and what it solves and what it
yes, sir.
doesn't solve. Okay, we'll have a discussion about that. Okay.
Thank you,
Yes,
sir.
sir.
Yeah.
Okay,
Yeah.
thank you, sir.
Yeah.
Thank you,
Remind me.
sir.
Remind me.
It was
You're
an
welcome.
Thank
interesting class, sir.
you.
Thank you.
Sure.
Yeah.
Thank you, sir.
Yeah. You're welcome,
Thank you,
guys.
sir.
Bye.
Sir, but if someone wants to leave, you can stay and just comment like what do you think.
Okay. The thing is, it'll be good if everybody listens in so they understand something. So I don't want to, I don't want to deprive them
So I
of
would
that.
like just a short comment, because whenever we talk
Yeah.
about it about Elon Musk, I'm not very much optimistic about Elon Musk and Web 3.0. Whenever I talk about it, and like
Okay.
every liberal and radical together like boo me out. So I thought to
Don't
discuss
worry,
it.
don't worry. Yeah. So let me clarify. Okay. The number one problem that Bitcoin, our Web3 solves, the Ethereum, Bitcoin, everything, all that ecosystem. So you have to understand inflation first. Okay. What is inflation? Okay. Inflation is money losing its value. Okay.
Yes, sir.
Money losing its value. And why would money lose its value? You earn 100 rupees today, and 1 year down the line, your money, 100 rupees, can only buy the value worth of 90 rupees, let's say. Okay. And why is that? Why does money lose value?
So because of the demand and supply keeps changing, and that changes the price of goods.
Not quite, actually. The reason is because money is constantly supplied through the central bank. Okay. All the banks, when you get a loan from, let's say, SBI, where does that money come from?
So the money that deposited, the people of the bank deposit there.
RBI
Okay.
RBI governs that.
Let me shock you guys. That money
Sir,
is created money. It's new money. It does not exist anywhere. It is just new money that the bank just created. At least 90% of it. Do you understand what I'm saying?
Yes, sir.
It's a created money.
In that,
The money does not exist at all. If you get a loan of 1 lakh rupees, 90,000 rupees is the money that was just created out of thin air by the banks. So what is that?
in that respect, I want to ask one question. Like it had been bugging me for a lot of time. So like when the money system was first initiated, like when the central bank first time printed its note. So like when they first started distributing it to the public, like what decided the value of those notes which they are printing?
Initially there were no central banks. There were only bankers. When it all started, there were only bankers. So what happened was this. So if you wanted to exchange goods across different places, let's say you're from Turkey and you wanted to trade with Pakistan, okay, and the medium was usually some rare commodity. You don't want to trade, you don't want to use as money some easily available commodity, then everybody can have money. Okay,
so it was perhaps it was referred as barter system.
Yeah, after barter system. This was after barter system. Barter system is extremely limited. You can only exchange with whatever you have. Okay, and if other person does not want it, then there is no way. Okay, you grow corn and somebody else is make tables, and if the guy who is making table does not want corn, you cannot buy a table with a barter system. But now, then if with money, you can always sell your corn to somebody who makes eggplants, and the eggplant guy will give you some money, and then you can give that money to the table maker and get the table. So money actually relieves you from the monopoly, from not monopoly, from the constraints of barter system. Okay, but with money, let's say people started using gold as money, but then you don't want to take the gold around. You don't want to travel with gold. Okay, because people will loot your gold. So what do? You go to a banker. What the banker does is he takes your gold, he puts it in the locker and says, he gives you a receipt saying that you have such and such amount of gold in the deposit. And that receipt becomes money. Okay, now you take that receipt to the guy who you're trading with in Pakistan or Turkey or whatever. Okay, you give that receipt to him, and then he gives you whatever you need, and then he goes and gets the money. He goes and gets the gold. Okay, so instead of gold, people started using these receipts, and these receipts were the money. These are called gold-based currencies. Okay, the whole world was gold-based. The currencies were gold-based up until 1960s and 1970s. Okay, and that's when Nixon, for various reasons, he said American dollar is not gold-based anymore. He took it off of gold denomination. Okay, which becomes free floating, and that's when all the whole world's trouble started. The trouble started because now you can make money out of thin air without any gold in your bank. Okay, if the money was gold based, then you can only issue enough money to the amount of in proportion to the gold that you already have in the bank. But if there is no gold base, you can basically issue any amount of money. The bank has started issuing any amount of money basically as loans, right? And that's what all the world's governments are doing right now. They are just issuing loans without any base. Well, what happens then is the amount of currencies in circulation increase. So when the amount of money increases, the price of things go up. Okay, if you're buying, if the currency circulation in India is 100 rupees, and if eggplant costed 1 rupee, and now suddenly you increase the circulation to 200 rupees, what will happen to the eggplant's price? It'll go to 2 rupees. Okay, but what happens is the people who get the loans, they are rich people, but the poor people, their money stays constant. Okay, if a poor guy was earning 3,000 rupees 2 years ago, he's still earning 3,000 rupees, but the inflation has gone up. Now the value of the money has gone down, which means prices have increased, which means he cannot afford anything. Okay, inflation is very bad for poor people, and this is one of the most important things that is solved by Web3, Bitcoin and Ethereum. Web3 is more general, but cryptocurrencies solve this problem of inflation, particularly Bitcoin. Bitcoin solves this because there is only a finite amount of Bitcoin that can be issued ever. And Satoshi Nakamoto, who created Bitcoin, this was one of his primary concerns. Okay, there is another concern, a huge, much more important concern. I'll talk about that later. But inflation is one of the big issues. Okay, and number two, yeah.
So one thing is that, as you said, in previous day we were following the gold-based money system.
Yeah, gold standard, yes.
Yes. So according to that, gold is as an exhaustible resources. At some time, it is going to be end. It going to be.
Yeah, it is exhaustible. Yes, it is exhaustible. Yes.
Yes, sir. So for in some time in future, if we follow the gold-based money system, that our economy will be going to be stopped.
No, it wouldn't stop. All that you have to do is instead of 1 ounce of gold costing $100, you say 1 ounce of gold costs $200. That's what people have been doing for a long time. They devalue the money.
So that's also been inflation because
Yes, exactly. That also leads to inflation. Exactly. That is, Roman Empire fell because of that exact reason. Roman Empire in 1 AD did exactly that. They devalued their currency. Instead of using copper, they started using other materials for their currencies, for their coins, cheaper materials. So they devalued their currency. They increased the inflation. Okay, and that they destabilized their economies. That is how that society fell. That's one of the reasons.
yes.
So inflation is bad. Okay, inflation is bad, but still countries keep doing it. Why? Because economy has to go on, economy has to perform. Okay, if you are not providing loans, you're not creating new businesses. New businesses always require loans. Okay, if you're not creating new businesses, you're not creating jobs. If you're not creating jobs, your people are suffering, your economy stagnates, if your economy slows down. If you want to create jobs, if you want to open up new companies, you need to loan amount, you need to loan money. And where does that money come from? It does not come from the government treasury. The government treasury is already assigned to various other things. Okay, the government cannot lend money for company making. No, it's the banks that do that. Okay, and that money is just out of thin air. It's not based on anything. It's not based on gold. It's not based on the deposits that the bank has. Nothing. It is just pure thin air. Okay, and
So one more question.
Yeah.
So actually, it is not related to this inflation and all these.
Mhm.
So everyone have actually heard about metaverse, something Facebook has started recently.
Yeah.
So can you explain how this is because I think that metaverse is somehow going to going to break down our society by separating us from reality and projecting us into a thing that is virtual reality.
That's a long way down. That's a long way down. Not right away. They are going to AR and VR, or augmented reality and virtual reality, but that's going to be a long way down. There's been multiple attempts that have failed. Google did that. Google did that too with Google Glass. It failed. So VR is very difficult to master. It's very difficult to master. Okay, let's see where it goes. Okay,
So, but
yeah.
let's assume that if we have mastered virtual reality, if we are projecting everything into a world that is not real, so is that thing is going to break down the actual human society that has evolved from the evolution of Earth? Because
See, humans have survived.
Nowadays, when we see that everyone has a smartphone, that thing has also somehow negatively affected our society. Human communication has decreased. People are suffering from depression and all those things. So
Yes, you're right.
in somehow future, if we are going to master virtual reality, is that going to ultimately break down the human values?
We don't know. We don't know. We don't know. We don't know how humans are going to adapt. Until the advent of smartphones, we didn't know. Like when I was having a brick phone, a dumb phone, I was happier. I was happier because I was talking to most people. I wasn't chatting. I wasn't typing anything. I was just chatting. I was talking to people, right? I was happier. Now, most of the times, I'm scrolling posts on Twitter, okay, which makes me sad most of the times. Yeah, but we adapt. We adapt really, really fast. Okay, human beings are nothing if not adaptable animals. So we don't know how things are evolve. Things are going to evolve, of course. The smartphones are bad for social cohesion. Because society is now split across different ideologies. Is unfortunate, and smartphones are to blame for that. Internet is going to it has to be blamed for that. But we are going to evolve. We are going to move on. Let's see where it goes. I don't know. It's a difficult question to answer. As for the Bitcoin, let me also say that the Bitcoin it solves a much bigger problem. The bigger problem is who does the money go to? Okay, if a bank gives out a loan, it gives out a loan to loan-worthy people. Gives out a loan to people who can repay that loan. Who are these people? They are usually well-off people. They're not the poor people. They're usually well-off people. Poor people cannot get a loan from the bank, right? So who decides that? There is centralized decision making. The decision making is centralized. And is centralized decision making good? Usually no. Usually no. And that is where the corruption breeds. Centralized decision making of any sort either in politics or economics or society. When there is centralization, there is corruption because a few people gain enormous amounts of power. And when people with power, there is a saying, absolute power corrupts absolutely. So even if the guy is completely honest, if he gains power, there is more than a fair chance that he will misuse that power. Okay, so centralization of power is dangerous, it's bad. And what Bitcoin does, what Ethereum does, is complete decentralization. Not one person is in power, it's decentralized. All the decision making is decentralized. Okay, there are multiple computers across the world solving hashing functions and coming to consensus on what is right and what is wrong, and what is which ledger is to believe, which sequence of history to believe, and they come to the conclusion without any centralized authority, without anybody at the center saying this is true. Okay, and that is an enormous change in how things are going to work. Okay, so far human societies have only had some central authority saying this is what we're going to do. Okay, that usually led to dictators, that usually led to a horrible financial crisis. Okay, that usually led to famine, like in China, like in the big leap forward during Mao's time. Okay, so these centralized authorities, these centralized agencies, centralized people, centralized decision making is dangerous for societies. We don't want to look up to one person to solve all the world's problems, because one person cannot comprehend all the world's problems. Okay, decentralized approach is the best for solving the world's problems, and that is one of the reasons why Bitcoin and Ethereum and all those are very good, because they are decentralized. There is no one single person taking a decision on what is right and what is wrong.
So, but decentralization, as many philosophers said, that decentralization is only possible in a perfect world.
That was before the discovery of blockchain, because people never thought that everybody could come to a consensus about something. Okay, if you take 100 people, if you put one problem, okay, if you pose one problem, the 100 people will have 100 different solutions. There is no consensus ever. But within a certain subset of problems, there can be consensus. Okay, and that is where the blockchain is. That is where the Bitcoin thing is. Okay, you can achieve consensus, at least with respect to transactions. Okay, you can have consensus in transactions without some central authority. Okay, let's say you go to Starbucks and buy a coffee, and you pay, and the Starbucks the barista says you haven't paid. Okay, and who is there to solve that problem? Okay, now today it's police, it's the courts. Okay, you don't need the police in the courts if the transaction is based on Bitcoin. Okay, the barista can be easily proven to be lying. Okay, you don't need the centralized authorities. Okay, of course, ancient philosophers, there is a limitation about in the earlier world, there was a limitation about how information can be shared and how many people can come to conclusion about certain information. There were limitations. You can only have 200 people within an auditorium, like maybe 1,000 people within an auditorium, they come to a conclusion, but that cannot solve the entire country's problem. If you want the entire country to contribute to problem solving, you have to have a network of that size. You have to have a network of the size of the country. You cannot assign some single person or a few hundred people to solve the country's problem. You have to have decentralized algorithms. Okay, and that is what blockchain gives you. Blockchain gives you decentralized stuff. Hello?
Yes,
hello? Sir. Yeah. So I'm not saying I'm not all in for blockchain. There is another problem with blockchain, which is called Oracle problem. I don't want to go much deeper into that. There is an Oracle problem, which is basically interface between blockchain and the real world, and that has not been solved yet. Okay, it's a big problem that needs to be solved, the Oracle problem. But hopefully they will solve it in the next 10 or 15 years, hopefully, with the Internet of Things and all that. IoT comes in a picture as well. It's a big, complicated field. There is a lot to talk about, but there's only so much time. Yeah, I hope that answers your pessimism to a little bit.
So actually, that guy left.
Oh, that guy left. Okay. All right. Okay. Yeah, I've spent too much time on talking about things, but yeah, it's fun. It's fun. Okay. All right, guys. Then I'll see you this Thursday. Yeah. Thank you, guys.
Thank you, sir.
Thank you. Thank you, sir.
Bye.
Thank you, sir.
Bye.